Ladies and gentlemen, we are here with a few guest appearances from the Geocon class. We've got
Dwayne "The Rock" Johnson.
Dwayne "The Rock" Johnson. Aiden.
And Trevor.
T-Rev Trev. All right, so we are going to go over the fundamental counting principle, which is a wonderful little concept here to figure out how many possible outcomes there might be. Woo!
It's randomly.
All right, so we've got a tree diagram is one way of figuring out how many possible outcomes there are. So if we are flipping a coin twice, how many outcomes are there? Well, let's say this. We got to flip a coin once. How many outcomes would there be? Two. Heads.
And tails.
Tails
guy.
Now, once I flip heads and I flip the coin again, how many possibilities are there?
An extra 2.
Yeah. So
Heads
four.
and tails.
Four
And if
total.
I flip tails on the other one,
Now
yeah, Aiden, you're right. Aiden's excited. He's thinking ahead. There are a total of 4 possible outcomes. You can go heads then heads then tails then heads, tails then tails.
Oh my god.
Woo!
Oh
And the
my
same
god.
concept for randomly selecting a 2-scoop cone of ice cream. All right? Wonderful.
Scared me. Wait.
So let's think here. We got a table or chart here that we could do. So a tree diagram isn't always the best. Let's say we're rolling 2 different dice, all right? Now, you could roll a 1 with one of them, and then you got 6 possible outcomes for the next, and then you roll a 2 and then 6 possible outcomes for the next. That's going to get quite cumbersome. So you could list them all out as 1 and 1, or 1 and 2, or 1 and 3, so on and so forth, to list out all your possibilities. So you could continue on, fill out the entire chart with all the different possibilities, but it's going to look something like that, and just woo, keep going. Yay, America, freedom, rock and roll. The last one would be 6,
Yeah.
Now, Dwayne "The Rock" Johnson over here had an idea about how many possible outcomes are there of rolling 2 die?
36.
36. So 36 would be the same as, well, 6 outcomes for one die, and 6 outcomes for the other, multiplied together gives me 36. And that, my friends, is the fundamental counting principle. Math. America. Very good, very good. So as a formal little slide here for you children, of the fundamental counting principle, all right? So that's what we just talked about. 6 times 6 gets us 36. We multiply each individual set of possible outcomes to get the total possible events.
I'll read it, Ellie.
Now we'll pass. You can pause and read if you so choose. So in a more formal mathy way to write it out, if there are A ways for one activity or event and B ways for a second to occur, there are A times B to both occur. And you can continue on with C events, D events, E events, and multiply them all together. And wonderfully, we've got all the possibilities. F events, G, H, I, Q, L, anything.
GRA.
Yes.
America.
All right. So let's see here. Trevor, where do you work? Denny's.
I work there too.
Hey, so does Aiden. All right. So let's say there's 10 entrees one could order. I know there's more, but let's say there's 10 entrees. And let's say there's
Moon's over my head.
6 appetizers and
Some cheese sticks.
12 desserts you can choose from. What would you do with all those to figure out how many possible meals you could buy if you were to get one of each?
Count them as they go in my stomach.
Oh, you could do that. Or if we multiply all those together, woo, we finna get 720.
You wrote 770 down.
That's I wrote 770. Hold up. You get 720.
It was a test.
That was a test. Very good, Aiden. Very good. All right, so very similar to what we just talked about as we made the wonderful mistake. I made the wonderful mistake, and Aiden caught me. All right, the club restaurant offers 6 appetizers and 14 main courses. What's the sample space, there we go, using some wonderful vocab, if a person orders 1 appetizer and 1 main course? Meaning, how many possible combinations can they have there if they got 6 appetizers and 14 main courses? Well, what would we do with these 2 numbers? Multiply them. 6 apps, 14
apps.
main courses.
Get 84.
84. I'm going to write it down correctly this time. Yeah.
Let's go.
Next one. We have a coin, if flipped, and a dice is rolled. I don't know why I said if flipped. I'm going to say is flipped. And a dice is rolled, and a card is picked. What is the sample space for these events? Well, a coin has how many possible outcomes?
Dose.
2. And a dice, 6, right? A standard, we'll say 6-sided die.
6, right.
And then a card in a standard card.
52.
52, very good.
Oh my god.
That's right.
Play last
All right, so what am I going to do with all of these wonderful numbers here to find out the total possible outcomes?
You would multiply them.
We'd multiply them. 2 times 6 times 52.
Off the top of my head, that's 624.
Very nice. 624 off the top of his head.
Well,
That was almost getting
so
right.
smart, Aiden.
I know.
Boom.
It's almost like you didn't use a calculator.
It's almost like he didn't use a calculator. So now, here's what we're going to be.
Is the calculator.
Yeah.
Ah.
Here's where this ends up going here, children, is, well, what's the probability if I was going to say flip get heads, then roll a 1, then pick out the ace of spades, right? I could use this as my total possible outcomes for those particular events. All right?
Particular.
Mm-hmm. Whew. So that will join in with a little bit more probability later. Alrighty, now we have an iPad that requires a password, 4-digit password, right? Numbers. You have that on your phone, you have that on your iPad, whatever. Alright, so this one needs 4, my phone needs 6, but whatever. Alright, so how many choices do I have to type in for the first number?
10.
10 choices, right? And when I'm doing these, I usually like to put like little notches here to fill them in. I got 4 spaces to fill, because we can do this with letters, with numbers, whatever. Now the second one, how many choices do I have?
10.
I have 10. I can repeat numbers, right? And the same will go through the entire time.
Over and over.
So if I multiply these 4 10s together, what do I get?
10,000.
10,000 possible outcomes, right? I have a feeling that your iPad will lock up before you try all 10,000, right, as a security measure. Otherwise, that wouldn't be very helpful. All right. Now, if I were to have said, like, hey, you can't repeat the numbers, then what would happen? If I said you couldn't repeat numbers with this password, I would start out with 10, then what?
9.
Then I'd have 9, then
8.
then
7.
boom.
What?
Cray, and I'd multiply all those together. All right.
Life's crazy.
So now we're going to tie in some probability along with this wonderful fundamental counting principle. So let's hop down. Actually, we'll hop back up. I'm going to hop back up. All right. So we use ratios to show how likely or unlikely something's going to happen. Right. So if we jump down here, a single flip of a coin, getting ahead on a single flip of a coin is what?
50% chance.
50, or we'll write it as 1 out of 2. All right. The probability of getting a red marble from a bag of 3 red and 2 blue marbles is what?
60%.
60%, or 3 out of 5, right? We'll usually write it as a fraction. You could write it as 60% or 0.6. The probability of getting a 5 on a single roll of a die.
1 out of 6.
1 out of 6, right?
6.
Perfect. So some very basic probability. So for probability notation, which you've likely already seen, we use P of A, or P of flipping a coin and having it land heads, or probability of pulling the red marble out, or the probability of rolling that 5. All right, so we could have notated them in this way. These are the same examples from before, just a more mathematically in tune way of writing it out. So now a little bit of thinky, right? What does it mean to have a probability of 0? I mean, what would be some examples here? Let's say I have that bag of red marbles and blue marbles. What would be a probability of 0?
Getting a yellow marble.
Yeah, getting a yellow marble.
Pulling out a banana.
T-Rev with the MVP move right there. Very nice. I like that.
Or pulling out
right?
a banana.
So, yeah, or pulling out a banana, or pulling out,
Dwayne The Rock
an apple,
Johnson.
or Dwayne The Rock Johnson. Very good. So what does it mean to have a probability of 1?
Only red marbles.
Yeah.
So, yeah, there you go. Say, yeah, if it's a bag of red marbles, what's the probability of pulling out a red marble?
1.
100%. Yeah, 1. Very good. It means that it's definitely going to happen, right?
Simplify.
Cool.
Same being on this phone.
Yeah, there you go. So we got an 8-sided die. That's cray. That's cray, man. Usually we're 6-sided die, but we're going 8 with this one. So be careful. All right. Determine the likelihood of these outcomes, right? So remember, the P in front means probability of getting a 3. So what's the probability of getting a 3 on an 8-sided die?
1 out of 8.
1 out of 8.
1 out of 8. Perfect. Probability of getting a number that's greater than 3.
Oh, wait. Hang on. 5 out of 8.
So we got 4, 5, 6, 7, and 8 are all numbers that are greater than 3. So as Aiden said, it is 5 out of 8.
I'm a smart guy.
Getting a value that's less than 10.
Oh, that's 100%.
100%.
100%.
That's right. That is our 1 for that one. How about getting a 12?
That's a 0%.
0 out of
Yeah,
8, or
no
just
chance,
0.
dog.
All right. Beautiful. that's it for this wonderful fundamental counting principle and a little bit of probability action. I thank you guys as being our special guests of Dwayne The Rock Johnson, T-Rev Trevor, and Aiden. America, freedom, rock and roll, and
Probability.
no, Costco.